Good morning. So we'll start session 4 on chapter squares and square root. We had completed, exercise what we started. We completed the first 4 means of the exercise. That is, we understood how to find the square root of a given number by a prime factorization method, right? So in today's class, what we will do is, for each of the following numbers, we will see it is not a perfect square, but with what we can multiply to make a perfect square and find the square root of that number also, again by prime factorization method. So let's start with the first one. I'll read the question once again. For each of the following numbers, find the smallest whole number by which it should be multiplied so as to get a perfect square number. Also find the square root of the square number so obtained. So first one is 252. Start prime factorizing it. 252. 2 ones are 2, 2 twos are 4, 2 6 are 12. So 2 6 are 12, 2 threes are 6, 2 threes are, it will not go by 2, so we'll try it by 3. 3 twos are 6, 3 ones are 3 sevens are, and 7 ones are, right? So now what we will do here is, we know that 252 is not a perfect square. These are few steps what you have to write, okay? Write down the factors of 252 what you have got. 252 is equal to 2 into 2, 3 into 3 into 7. Suppose if this was a perfect square, then we would have equal pairs of 2, 3 and as well as 7. Now here when you see 2 has a pair, 3 has a pair, 7 is left alone. So whatever is left alone, okay, assume that we have one more number 5. That means 7 and 5 are left alone. So 7 5s are 35 is a number to be multiplied, right? Like that. So here we have only 7 left alone. So to make a perfect square, we want one more 7 as a number to make it a pair. Therefore, write the question what they have asked here. We can say that 7, they have asked by which smallest whole number. 7 is the smallest whole number which should be multiplied, these steps you have to write it compulsory, multiplied to 252 to make it a perfect square. Okay, so what we will do now is we will multiply 252 into 7. How much do you get? You get 4 6, yes, 1764. You get this. Right? Now what is our next step? They have also asked us to find the perfect square of the number finally formed. Now I don't have a space here, children, so I will be doing this beside. But you are supposed to do this one below the other, right? So after this continued, you have to do it here only. I will be doing it there. 1764. Factorize. 2 8s are 16. 2 8s are 1 carry over, 2 2s are 4. 2 4s are 8, 2 4s are 8, 2 1s are 2. 3 1s are 3, 3 4s are 12, 3 7s are 21. 3 4s are 12, 3 9s are 7 7s are 7 1s are. So square root of 1764 is equal to root of 2 into 2, 3 into 3, 7 into 7. See the pair here, right? So this is 2 into 3 into 7. 2 3s are 6, 6 7s are is 42. So square root of 1764 is 42. This is how we are going to solve this. First find the least number to be multiplied, and then after multiplying find the perfect square of the number obtained. So now we have got an idea, children, how to do this. Okay, let's do one more sum. Right? Similarly, first let us see what is the least number to be multiplied. I hope you are doing the homeworks. Children, what I am observing is the videos, what number of views, what I can understand, what I come to know from the videos. You are not watching the videos on regular basis, right? So it's going to be lost for you if you don't watch them on regular basis and ask me doubts regularly. Later, once the chapter is done, once I send the video, after that I will be not clarifying any doubts on the same. It will be only done in the regular classes once we start during revision time. Make it a point of watching it on the same day of the video set. So the next one we will start. Again, I will be giving you some homework here. You have to be very perfect in the prime factorization. So the next is 180. Now 180 also will do the same thing. Okay, I will do one thing, children. I will not do 180. Okay, remaining ones you can as well take it for homework. We'll factorize this. 180. 2 nines are 18, 0. 2 fours are 8, 2 fives are 5 nines are 3 threes are 9 and 3 ones are 3. Again, what is the step we wrote? We know that 180 is not a perfect square. Okay. So factors of 180, how did we get? 2 into 2 into 5 into 3 into 3. So 3 is a pair and 2 is a pair, 5 is left alone. Therefore, 5 is the smallest whole number with which 180 must be multiplied to make it a perfect square. I have just skipped the lines what I have to write. It is the same thing what I have written from the previous one. So when we multiply 180 into 5, what is 18 fives are? 18 fives are is 90. So it is 900. Now 900 is a perfect square, children. I am doing it here. So for 900, when we see, we start from 3. 3 threes are 9. 3 tens are, 3 hundreds are, 2 50s are, 2 25s are, 5 fives are, and 5 ones are. Square root of 900 is equal to square root of 3 into 3, 2 into 2, 5 into 5. So make a pair. What do you get? 3 into 2 into 5. 5 2s are 10, 10 3s are 30. So square root of 900 is 30. That is how you do it. Third, fourth, fifth and sixth one is your homework. So I hope you have got the previous one. Similarly, we have to follow this. First find the least number and then make it a perfect square. I'll write the homework list now. Now next one is same thing, but we have to see that by what number it has to be divided. That is what they have asked. So let us see how to do that. Again, I'll be doing first one or two sums. Please also practice the worked examples. So today's homework from the fifth mean, which you will be doing is third one, fourth one, fifth one and sixth one. Okay. Sixth mean, for each of the following numbers, find the smallest whole number by which it should be divided so as to get a perfect square. Also find the square root of the square number so obtained. We'll again start with the number here. Same, 252 only they have given. Let's start with that, but it is not multiplied, it is division. 252, factorize this. 2 ones are 2, 2 twos are 4, 2 six are 12, 2 six are 12, 2 threes are 3 twos are 6, 3 ones are 3 sevens are and 7 ones are. We know that some few steps will be seen. 252 is not a perfect square. So factors of 252, whatever you have got, you write here now. 2 into 2 into 3 into 3 into 7, where 2, 3 made a pair, 7 is left alone. Therefore, what they have asked here, children, to be multiplied or to be divided. Now here the fun is, whatever is left, you have to divide it. Even if a number is left, combination of, assume that 5 is left. Even 5 is left alone, 7 5 is 35. Example, 35 should be divided. Not 35, but I told you, right? Whatever is a number without pair, that has to be divided. So 7 is the smallest whole number, by which 252 should be divided. So 7 is the smallest prime, so the given number 252 should be divided to get a perfect square. So 252 divided by 7, what do we get? So 7 3s are 21, 4 remainder, 7 6 are 42. We got 36 as a number. So we all know directly it's a very simple number, 36. You want to factorize 36 or directly you want to write it, is up to you, children. 36, don't write from 6. 2 ones are, 2 eights are. As I don't have a space here, I am doing it beside. 2 nines are, 3 threes are and 3 ones are. Square root of 36, we know answer is 6, right? 2 into 2 into 3 into 3. Factors and pair. 2 threes are, square root of 36 is 6. So that is the question asked and that is how we have solved it. Similarly, we do the next one. 2925. Now what I do is I only rub this part so that I can do just the fill in the blanks kind of thing. It will be easy for me. Okay. So second is the number 2925. So 2925, it has to start from 5. So 5 5s are is 25. So or see one more thing. Okay, before we start with 5, let me tell you, is this only divisible by 5? First check. By 2 it is ruled out. We cannot divide by 2. I know ending is 5, so we start with 5. Is it divisible by any other number also apart from 5? How do we check it? Add and see what do we get. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So sum we get as 18. So 1 plus 8 we get that as 9 also. So this number is not only divisible by 5, it's also divisible by 3, right? Just to check. Let's start from 3. So when we start, 3 nines are 27. So 3 nines are 27 when we get here. So we get a remainder. 3 sevens are 21. 3 fives are 15. Further again by 9. 3 threes are 9. 3 twos are 6. 3 fives are 15. Now again, by 5 or by 3 decide. 5, 6, 7, 8, 9, 10. Not of course by 3. So by 5, 5, 6 are 30. 2 remainder. 5 fives are 25. So 5 ones are 5, 5 threes are 15, then 13 ones are 13, right? So we know that 2925 is not a perfect square. So 2925 is equal to 3 into 3, 5 into 5 into 13. So 3 has a pair, 5 has a pair, 13 does not have a pair. 13 is the smallest whole number by which 2925 should be divided to get a perfect square. So 2925 divided by 13. So when you divide this by 13, you will get the answer as 13 twos are and 5s are 225. Is 225 a perfect square? Yes. So let's start. Which perfect square it is? 15 square is 225, right? 225. 5 fours are 20, 5 fives are 25, 5 nines are 45, 3 threes are 9 and 3 ones are 3. Square root of 225 is equal to square root of 5 into 5 into 3 into 3. Sometimes we write and forgot to write the square root for the whole 3 also. Don't do that. It should be for the whole number. 5 and 3. So 5 into 3. Square root of 225, answer is 15. There we get it, right? So similarly children, I want you to do again here. 6th main, 3rd one, 4th one, 5th one and 6th one for homework. Complete this for homework. Similarly, how you do it? First factorize it and then find the square root of that. We'll directly go over the next main. It's a verbal sum. The student of class 8 of a school donated rupees 2,401 in all for a Prime Minister's National Relief Fund. Each student donated as many rupees as the number of students in the class. Find the number of students in a class. So this has to be a perfect square because number of students donated that many means double what we see. We get the answer as 2401. Let's see. Let's write down as a statement and do it. So let 7th one, let the number of students be x. Okay, since each student donated as many rupees as the number of, same thing from the question what we have I'm writing, as the number of students in class, that is given as rupees x into number of students, that is nothing but x squared. Okay, that is what they are given here is. So by data, amount what you can say is amount donated by class 8 is equal to rupees 2401, right? So this implies x square is equal to 2401. So transpose children, like plus transposes to minus, minus transposes to plus, division to multiplication and multiplication to division. A square when we transpose, that becomes a square root. So how do we do this? Let us factorize this. 2401. Now, the thing is now 2401 we have to factorize. So first of all, it is not divisible by 2. Then not by 5 also. Let's check with 3. 4, 5, 4, 5, 6, 7. The sum is 7. So it is not divisible as well as by 3. Now what to do? By 4 it will not happen because again 4 has a different condition. Again it has to be even number children. We know that 4, 6, 5. What is left out there? 9 also will not come because same as 3. The left is only 7. We can give a try for 7 because 7 also has a table ending with 1. 7 3s are 21. We have, right? So we can give a try with 7 and it has to be by 7. 7 3s are 21. So 7 4s are 28. 1 remain, 2 remainder. 7 3s are 21. Yes. 7 4s are 28. You can give 7 9s are 63. 7 7s are 49 and 7 1s are 7. Square root of 2401 is equal to square root of 7 4 times into 7 into 7. So 7 into 7, square root of 2401 is equal to 49. Give the concluding answer and write it here. Therefore, the number of students in class 8 are 49. Now they have not asked the amount donated. If they had asked amount donated by each student is also 49. Okay, that's how the answer is. Let's quickly go with the next one. 2025 plants are to be planted in a garden in such a way that each row contains as many plants as number of rows. Find the number of rows and number of plants in each rows. Now again here, number of rows and number of plants in each row are the same. So when we multiply number of rows and each rows in a plant, in each rows how many plants are there, that becomes the square of that particular thing. So let's again begin with the same thing. So this is how you have solved it. Let's delete. It is the same in linear equation how you gave the conclusion. Since it was a verbal sum, conclusion is must and should. So let the number of rows be x. Then what they have asked? The number of plants. Let the number of rows be x. Then number of plants in each row be also x only. Why? Because they are the same number of rows in each number of rows as well as number of plants in each row is also x according to them. Next, therefore, number of plants to be planted in each row. What it has to be? X into x, that is nothing but x square. By data, what they have given? Total number of plants to be planted. Total number of plants to be planted is equal to how many? 20, 25. This implies x square is equal to 20, 25. Transpose goes to other side, becomes square root. Now if you ask the type of question given, if it is not a square root teacher, then what to do? It depends on the given question also. The given question only will be like that. It has to be a perfect square. Such questions are only chosen. 20, 25, directly start from 5. So see here, 5 4s are 20. What mistake we all do the next one is, we write off 5 5s are 25, right? We all do. But in division, suppose if the number was like this, 5 4s are 20, 0. Then we take only one number, right? That's a division rule to take. But since we cannot divide it, we should take one more number. So we add one 0 there, right? So here also same rule applies. 5 5s are 25. This should be carefully done, this part. Okay. 5 8s are 40. 5 8s are 40. 5 1s are 5. 81 by 9. 3 2s are 6. 3 7s are 21. 3 9s are, 3 3s are, and 3 1s are. I'll do this beside here. So square root of 2025 is equal to square root of 5 2 times into 3 4 times into 3 into 3. Group them. So 5 1s, 3 into 3. 3 3s are 9. 9 5s are is 45. Square root of 20 25 is 45. Conclusion. Therefore, what we have to give? Hence, the number of rows is 45 and number of children, not children, number of plants, I'm still in the previous sum. Number of plants we'll write in each row. Is 45. I'll give you one trick for this 5 multiplication here. Suppose in exam tomorrow you come across any multiplication, say that you just get a question, square root of 35, square root of 75, square root of 45. You need not sit and multiply. It works only with the 25. Let's take this one only. 45 square you have. That means you have to multiply 45 into 45, right? Always first thing what you have to remember is, whenever we square 5, the answer is going to be 25 in the units and 10 places. That is fixed. What number do you have here? 4. What is the next consecutive of 4? After consecutive is the next number. Next consecutive of 4 is 5. 5 4s are 20. 20, 25. This only works with 5. This does not work with any other number, because this will help you in multiplying higher order numbers in the square root part or something if they ask. Let's check now. See, what is 25 square? We know that the answer is 625. Just check. 5 5s is 25. Consecutive of 2 is 3. 2 3s are 6. So that is how you can multiply. If any such bigger number is there and it is asked for just 1 mark question, MCQ kind of a question, you need not waste your time in finding. So since it is such big, you can actually start. Okay. So let's proceed with the next one. 9th one. What they have asked, it is a bit different one than what we have done till now. This actually comes under Vedic mathematics, children, about tricks in calculation which works out with 5. You actually also learn this in the square and the algebraic equation squaring also. There also we have some tricks of finding the squares. But this is one of the method which you should know in the square root part. And that goes very well with 5. So find the smallest square number that is divisible by each of the numbers 4, 9 and 10. So one smallest number which is divisible by all the 3 numbers. We can't be doing that orally, so we have to solve. There's a particular technique for this. So when such numbers are given, now what are the numbers given? 4, 9 and 10, right? So there's a like few steps for that. The smallest number divisible by each one of 4, 9 and 10 is equal to the LCM of 4, 9 and 10. Means the smallest number is equal to the LCM of this number. That means find the LCM. So LCM we will find here. It is 4, 9 and 10. All by 2 will start first. 2 2s are 4, 9 as it is, 2 5s are 10. Right? So next what we will do? 2 1s are 2, 9, 5 as it is. 3 3s are 9, 5 as it is. So 3 1s are 3, 5 as it is if you want. Then 5 1s are 5. This is how we take LCM. I did not explain this. You have done this in your lower classes. This is the common LCM method how we take. Right? So this is the LCM part. So LCM is LCM of 4, 9 and 10 is product of this. So 2 2s are 4, 4 3s are 12, 12 3s is 36 and 36 into 5 will give you 180. Right? So we got 180 here. So what we will do now? Prime factorize 180. That's our next step. Since I do not have space children here now, I'll be doing it here, but this has to go one below the other. So 180 when you prime factorize, 2 9s are 18, 0, 2 4s are 8, 45, 5, we have done already 180 factorization, 5 9s are, 3 3s are and 3 1s are. So factors of 180 are 2 into 2 into 5 into 3 into 2. Now when you see that here 2 and 3 have pair but 5 does not have a pair. So we can write here, what we can write here is clearly to make 180 a perfect square, it should be multiplied by 5. 180 into 5. 18 5s are its children, 90. So 900. Right? Got it here? So 900 according to the question. 900 is the smallest square number. That is what they have asked. Find the smallest square number, perfect square number. 900 is the smallest perfect square number that is divisible by each of these numbers. What do we do for this first? First of all, whatever they have given, we find the LCM of it. We get LCM, one number. That number we prime factorize. That being not a perfect square will have one unpaired factor. With that unpaired factor, what we do? Least number to be multiplied we give. So with that what we say? What we get here? Therefore, 900 is the smallest square number. Enough. Or the conclusion you can give here. So we have a similar question of a 10th one. So 900 is the smallest square number. Yes, even here you can write the smallest square number. That is important because it is not only the number, square number we require here. So similar is the next one. Find the smallest square number that is divisible by each of the numbers 18, 15 and 20. So one more part in homework, children, 10th week. Same thing, what you do is first find the LCM of 18, 15 and 20. Then what about LCM you get? Prime factorize that. That will not be a perfect square. That will leave some unpaired number. That unpaired number you multiply to that prime factorization number, make it a perfect square, and that is the smallest perfect square number divisible by each of the given numbers. With that we complete this exercise and we complete finding the perfect squares by prime factorization method. So our next session will be finding the perfect squares by long division method or division method, what we call. That is I think it will be for the first time we will be studying a long division method to find a perfect square. Why did we introduce that method? Because this was very simple. The thing is, now this can be done if you have very small numbers, right? But if you have numbers in terms of 10,000 or very big numbers, so prime factorization is very difficult. It goes pages to pages. It goes very lengthy prime numbers in that order. So to avoid that, we have a division method which gives you a very quick answers by 2 or 3 steps with the perfect square. So we'll be doing that in our next session. So complete your homework.